This is laminar.io. Take this 5-minute video of a private brain MRI scan at 30 FPS. In our scenario, these are scans of patients that may or may not have malignant tumors in their brains that are being used by Hopkins researchers attempting to create an algorithm that will diagnose these patients in seconds. The problem is, these researchers have to go through each frame of the patient scans and label them individually for their networks to train on. Let's go back to the image. 5 minutes at 30 FPS. That equates to about 9,000 frames. If we assume each frame takes 5 seconds to annotate, one patient MRI scan would take about 12.5 hours to annotate. And to train an algorithm, you need hundreds of data points. So let's visualize that. As you can see, this would take endless hours of merely data labeling to train these networks. So how exactly do we label these frames efficiently?
So this is a difficult question that we're hoping to answer. And one of the main big problems with this is that the manual frame labeling. Because you can have so many frames, having to manually label them can take a long time, upwards of many hours. And the next big problem that we have also is that when people try to deal with this issue, is they often hire or vet experts to assist with their labeling, which is of course costly, time consuming, and takes many resources. And finally, perhaps the biggest issue is with hiring is they also hire external crowdsourcing firms, which are even more expensive and take more resources. And so, if we consider ourselves in the context of our competitive landscape, we can see that the difference between us and our competitors is that we are implementing crowdsourcing in an existing ecosystem, while many of our competitors lack crowdsourcing or do not implement machine learning approaches, for example.
So while the existing competitors tackle the problem in different ways, researchers building these machine learning models need a way to more easily and quickly access crowdsourcing resources while also maintaining the confidentiality of their private health data. That's where we come in. We plan to implement crowdsourcing within an existing Hopkins ecosystem that maintains confidentiality. Our solution is going to be integrated into current Hopkins ecosystem IT infrastructure, such as the PMAP system, um, underneath the Azure system. And the data will start off in the cloud, head to the Laminar IO, our app, interface with the labelers, who will then send back their labels to the data storage area where researchers can then access their data for the machine labeling algorithm. We plan to start at the Hopkins Homewood level, expand to a secondary market of external academic institutions, and hopefully turn up as an interface tool for all Azure users in the future. We're currently in the designing MVP phase. We're currently considering a partnership with Microsoft startups, and we're building our prototype at the moment. And in the future, we're going to be implementing a pilot study and iterating in the future. I'm Viggy.
I'm Otis.
And I'm Will.
Thank you.